The Autostrada per l'Italia Group, a leader in the Italian motorway sector, manages a vast concession network spanning 3,000 kilometers, representing about 50% of the Italian motorway system. This extensive network covers 15 regions, with 4,200 bridges and viaducts, over 420 kilometers of tunnels, and 9,100 employees. The group has a diverse range of expertise, from engineering to construction, from sustainable technologies to innovative mobility services, allowing us to efficiently manage a complex network that is essential for the movement of people and goods within the country. In 2020, the Ministry of Infrastructure promoted a massive assessment on structural tunnel conditions. Autostrade per l'Italia, responding to this high demand for maintenance work, mainly related to a significant part of the network built before the 1970s, has developed a new approach to renovate the existing tunnel asset, named Tunnel Renewal Strategy, TRS. TRS is a comprehensive approach which aims to achieve the service life's renovation of existing tunnels through different innovative relining solutions. The Manfreida project is the first to be completed out of more than 40 ongoing design applications. The southern carriageway of the Manfreida tunnel was constructed in 1977 and is situated on the A26 Genova-Gravellona Toce motorway in the vicinity of Genoa. It was originally a monocentric twin tunnel with a winding trajectory, measuring 787 meters in length and 15.5 meters in width, allowing for 3 lanes in each direction. The tunnel was excavated through calc-schist metagabbroic rocks and serpentine schist. The maximum head above the tunnel is 138 meters. The rock mass on the Genoa side is highly fractured. The existing lining was thoroughly inspected and tested to assess its condition and identify the optimal treatment solution. The 90 centimeter thick original liner was deteriorated mainly due to the lack of a waterproofing system and to the poor construction technologies adopted at that time. The concrete casting technologies used at the time of construction unquestionably resulted in the creation of several hidden cavities in the tunnel lining. The design of the solution was based on the consolidation of the voids by means of nailing and grouting in order to safely proceed with the refurbishment and relining of the tunnel in the subsequent phases. Milling and hydro-milling were used as appropriate, depending on whether the original lining was reinforced or not. The polycentric milling shape was designed to minimize demolition at the crown and maximize it at the sidewalls, as you can see. This system provides the highest level of operational safety, ensuring the necessary clearance for vehicles in lateral lanes. The supporting beams were designed on both sides with anchors to provide a proper foundation and connection for the new reinforced lining. We have identified that the deterioration of the existing linings is primarily caused by circulating water. To address this, we have designed a robust waterproofing sheet and drainage pipes to collect and dispose of the water coming from the surrounding rock mass. The innovative waterproofing system is made of 3 pre-assembled layers and installed on the existing lining by Velcro strips. The cages were designed to be delivered on-site in 3 pre-assembled modules with proper bolted joints and few additional rebars to be installed, making this phase faster when compared with the traditional reinforcement. The decision was made to reline with high-performance sprayed concrete due to its unparalleled flexibility from both a geometrical and operational standpoint. The tunnel's unique shape made it clear that any other alternative relining solution, such as precast segments or cast-in-place concrete, would have been impractical. During the lining refurbishment of the Manfreida Tunnel southern carriageway, an amazing machine was deployed in the opposite direction, the road zipper. It's around 3 meters wide and more than 30 meters long. As the name suggests, this machine, by physically moving a specially designed concrete barrier, can radically modify the layout of the highway in seconds, Based on the changing needs of peak traffic, the machine was zipping up and down the northern carriageway multiple times a day, reconfiguring the road without having to build a new lane. The road zipper is a big innovation, since you can mitigate congestion due to a tunnel closure with your existing opposite direction highway capacity. To change the layout, the road zipper uses a system of rubberized conveyor wheels. As the operator drives forward, it gently lifts and shifts the barrier diagonally across the underside of the machine. Crucial to the system is the barrier itself, made up of hundreds of interlocking 1-meter sections. The 700-kilo T-shape elements are linked and articulated by metal pins, making the barrier an ultra-strong but flexible chain. By traveling at a speed of up to 8 kilometers per hour, the machine can zip a 2-kilometer barrier in just 15 minutes. As well as keeping traffic moving, it creates a safe divide between vehicles, which are traveling towards each other at dangerous speeds, something that humble traffic cones cannot do. 2 lanes were always guaranteed to the main flow direction, keeping both the drivers in the tunnel and the project's road workers safe. Finally, the road zipper enhanced time saving, cutting months from the schedule and allowing the reopening of the southern carriageway in advance.